Hello and welcome to the state tree tutorial for Unreal Engine 5.1. In this tutorial I'll be walking through the steps for setting up an AI using state trees. If you want additional information on how these state trees work, please check out the Unreal Engine documentation for state trees, where the link can be found in the description. I will, however, try my best to explain the practical processes that you should keep in mind when working with state trees. The tutorial will be timestamped in case you want to skip or go back to certain sections in the video. So let's begin. Our first step is to create a project, and for this I'll be using the third-person template project. There's a few steps that will need to be made before we can actually start using state trees. And these steps involve activating the state tree plugin, as this does not come activated by default. I'll be showing you the steps of how to do this now. First, you'd want to go to the very top left where you can find your edit and go into your plugins. Here you want to search for your state trees, and there's two tabs that you will want to click: the state tree and gameplay state tree. Once you click both of these, the Unreal editor will prompt you to restart, and just simply restart. So before we start with setting up the state tree, we will need to set up a few blueprints in our project. This is the AI actor blueprint and the AI controller blueprint. I'll speed up the process where I create the character, as this is a pretty standard process in Unreal. Okay, now that these two are set up, we're going to want to go into our tutorial character that we just created, and in class defaults we're going to want to search the AI controller class. And here we're going to want to set it, click on the drop down and set it to our AI controller that we created. Once this is done, compile and save, and that's our first step done. Now we're going to want to enter the tutorial character, and in the tutorial character we're going to want to add a new component, which is the state tree component. This is going to be the most important component, as without this nothing will work. When you click on the state tree component, you can see on the right side a state tree and a drop down that has none. Right now this is empty, but once we create our state tree, this is where we will add the state tree that we want the character to use. So now that we finished creating our character, we're going to want to create the actual state tree. For this, we're going to want to right click the folder where we want this to be in, search for artificial intelligence, and press state tree. You're going to want to click the state tree component, and here you can just name it to st underscore and then whatever you want here. For this example, for this tutorial, I'll just have just st tutorial. So once we created our state tree, we want to go back into our tutorial character, press the state tree component, and in the state tree tab on the details tab, we want to press our none, and you will see how the tutorial state tree that we created is now available. We want to press this, compile and save, and it's done. So once you've finished setting up your state tree here, you're going to want to add a NAVmesh into our level. For this, we want to go up to the top left here, where there's the box in the cube, press it, go into our volumes, and we're going to want to click on the NAVmesh bounce volume. Now I want to drop this down, move this in the middle of our level, scale it to the size we want. For now, I'll just scale it to be really big. With this, you can also press P, and you can see how the NAVmesh gets created, and you can see all the areas that the AI can move into. So open up the state tree you just newly created, and this will open up the state tree window. So on the very left side, you will see your state tree tab. And here, you can find your context actor class. You can find this by clicking the arrow here to open up the drop down. Here you'll find your context actor class. This is where you can set a direct reference to the character you just created. So for now, let's start by doing that by pressing it and searching for our tutorial character that we just created. And simply select it. Done. Furthermore, in this tab, you will also find parameters and evaluators. What evaluators are, I'll explain later. As for what parameters are, I'm not exactly sure how these are used yet, so I can't really explain what these are. In the middle, you'll find another state tree tab, which should not be confused with the state tree tab on the left, because this state tree tab is where you will find all your states that you can edit and control their execution. As for what a state is really just this blue box that you can click on it, and this will pop up additional information on the right side in the Details tab. So before we continue, you must understand that state trees as a whole function by selecting states and setting the selected state to active. The state tree will then run the functionality within the active state. Essentially, it will run the code in those states. And the advantage that state trees have is that you can precisely control what states you want to set as active states to transitions. And what transitions are? Well, transitions are just selecting which states the state tree should move execution to. So whenever you click on one of these states, you will find on the very right side the Details tab, which will contain enter conditions, task, and transitions. Tasks contain the specific code that will be run when a state is selected, and these tasks are essentially commands that you can give the state tree to run when it enters a state. One good thing to note is that you can have multiple tasks in a single state, and to add a task, you simply want to go into your Details tab where your task panel is and press the plus button here. You can then press this drop down right here, and you can add essentially the tasks that are already created, which are these two, but you can also add your own task that will all appear here as you start expanding more on the tasks that you create. When you add a task, you can then press this arrow button right here just next to the task that you created, and you can start to see all the variables that you can edit in that task. You do have to keep in mind that these variables have to be set yourself. I'll explain how to do this in a bit. And as I said, you can add multiple tasks if you want. Next up is transitions, and transitions are where you can control when and where the state tree execution will continue, or essentially move to, once certain conditions are met. You can also remember that you can add multiple transitions and multiple conditions to your state transition. Do note that when you add multiple conditions to a single state transition, that it will consider itself as an AND variable. You can also switch it to an OR if you want. Whenever you press the AND, it will pop up AND or OR, and you can essentially press this and switch it around. Enter conditions are similar to the conditions in transitions. The difference is that these conditions will be checked the moment the state is selected, and this will either allow or prevent the functionality in the state to run depending if the condition fails or not. For example, if you set a simple Boolean condition to check if, for example, the character was jumping, if it's true or not. If you want to set it to if the actor was jumping, it's true, but it turns out the actor wasn't jumping, it's not going to run any task within this state. Anyway, returning to the middle state tree tab, you need to understand about how parent and child states behaves is the following. Also, really quick, if you want to add a child state to a parent state, you would right click the parent state and add child state. So what you need to understand is that whenever a child state is active, any task in the parent state will also be run at the same time. Because the way state trees work is they work on a top-down perspective, meaning that, let's say this child state had additional child states. If this was selected, it will then run the task in this child state here, and then the task in this other parent state. So now that you hopefully understand a bit more of how state trees function, we can actually get to creating our AI. Also, if you still don't understand this, you can also check out the documentation that Unreal Engine has, which hopefully should explain how these behavior works. So for this, we will create an AI that will move towards the player, then jump when it gets close enough to the player, wait a few seconds, and repeat the behavior. So to begin, we will need to track the player's location. To do this, we can either make a task that will get the player location and save it as a variable, or we can make use of an evaluator that will constantly keep track of the player's location and return this as a variable that we can use anywhere in the state tree. So for this tutorial here, we'll make use of an evaluator. And to explain what an evaluator is, it's similar to a Blackboard for behavior trees if you've ever used it. However, with an evaluator, you can run your own custom code within it from the moment the state tree runs, and you can even run it on tick, which will basically allow you to essentially keep saving a variable on tick if you'd want. Additionally, the variables from this evaluator can be set to be accessible at any point in the state tree. So let's begin by creating our evaluator. For this, we'll create a new blueprint, and in here we will want to search for state tree evaluator. Here you want to search for the state tree evaluator blueprint base. Select this, click select, and name this EV underscore, for now we'll name it player tracker, but you can name it whatever you want. Next we want to open this up, and in here we'll want to start creating our actual functionality for tracking the player and saving it as a variable that we can use later. To do this, we want to go into the very left into the My Blueprint tab, find the Functions section, hover over it and press Override and press the tick function. So now we'll just create a functionality for getting the player. So we'll want to get the player pawn. This way we can get the player location. And this actor location we want to save as a variable. We can right click this return value here, promote to variable, and here we can name it just player location. And with this we essentially have the functionality that will save the player location for us. However, there's something that state trees use for their variables, which you can categorize variables in input and output variables. For now, we'll categorize our player location as a output variable. For here, we want to click on our player location variable that we just saved, go into the details tab to our category section, and simply name this output with the O as a capital. This will set our player location variable as an output variable, which we can use in our state tree. I'll explain what the input variables does in a second, but for now, this is what is required to actually get the player location working. So we want to go back to our state tree, and now we want to actually add our evaluator into our state tree. For this, we want to go into our state tree tab at the very left, search for evaluators, press the add element button. Here, when we open the drop-down, now we should actually be able to see an EV player tracker appear. When we press this, we will now have it as an evaluator in our state tree. You can then press this little drop-down here to see all the variables that are visible in the tracker. As you see, we can see our player location variable seen as an output property. Next up, we want to create our actual state that will contain the functionality for making sure the character can move. For this, we would want to select the child state that we created previously, and if you don't remember how to do this, you want to right click your root state and add child state. For now, we'll just name this movement, and we'll delete this other one for now as we don't need it. Click on the movement state, go into your task, and you want to add a new task. Do this by pressing the plus sign at the very right here. You can then go all to the very left and click this arrow button, and it will show our task here. You can then click this drop down, and as you see, we don't actually have any task for making sure the character can move, so that's what we're going to create now. So next up is creating our custom movement task. For this, it's the same process as how we added our evaluator. You want to right click, search for blueprint class in the all classes. Instead, we want to search state tree task. And here you'll see state tree task blueprint base. Click it, select it. And here we will name it STT movement. Normally you can also just change this or name this anything you want, but for now we'll just name this STT underscore movement. Double click it, open it, and the same way we want to go into our functions tab, override, and for this we will want to put it on the untick. You can also put it on the enter state, which essentially means that the moment the state enters and the task starts to get executed, this will run once. I'll get back to this later in another task that we'll need to create later, but for now we'll just simply create this tick task. This is where we can use the input category for the variable. So for now we'll create a new variable and we will name this player location. Remember to put this as a vector, otherwise it won't work. In our details tab, we will go to our category and put this as input. Remember to put the I as capital. Now that that's set up, we want to create our actual functionality for moving the the AI, and we can simply use this with a simple move to actor or simple move to location. For now, since we have it as a location, we want to put it as a simple move to location. Here you will see that we require a controller reference and then the actual location reference. We already have the location reference, so we will just want to drop this in and connect it to here. And to actually get our AI controller reference, what we can do is we can go back into our evaluator player tracker, and instead we will want to go into our functions, override, and click on the 3 start. With this, we're going to need two things. We're going to need a reference to our AI character, and then using that reference, we'll need to find the actual AI controller. So let's start by getting the AI controller node. Using this, we can promote the return value into a variable and set this as AI controller. We can simply move this into the output category, and that's that. Now to actually get our controlled actor, we're gonna need to create a new variable. So we're just gonna name it AI character reference. And here we want to search our reference for tutorial character. Drop it in, put it here, connect it to the get AI controller, and put this in the input category so we can actually bind the actor, the context actor, to this reference. So we're going to go back to our state tree. In our evaluator, we will see our AI character reference, and we want to bind this to the actor, which is basically our context actor here. We now should have a reference to our AI controller. So when we go back into our SCT movement blueprint, so we're going to want to promote the variable in the simple move to location, promote this, and simply name it AI controller. We're going to want to move this into our input category, and that's done. Now with this, we're going to want to go back into our state tree, click our state that we named movement. In our task, we want to add the SCT movement that we just created. Click on it, press this arrow here so you can drop down to see more information, and here you will see how the AI controller and player location have both an in next to them. This means that a variable has to be bound to these two variables, otherwise the state tree will give us an error. For example, if we try to compile now, we will get a result showing us that the two variables are expecting binding. So for the AI controller, we're going to want to bind it to our AI controller in our evaluator. For this, you press the bind, it will show up a drop down, and you can see how it shows our evaluator, our EV player tracker. We want to hover over it, and then we want to hover over our AI controller and press it. As for our player location, we will repeat the same process, into our player tracker, and then player location. With that, it's done. We can now compile and save. So now that we're done with setting up our movement state, just to show that this is working, we're going to want to drop in our character into our level and simply play. Remember to actually have a NAVmesh in the level, otherwise this will not work. As you can see, our character will now follow us, and this means that the AI is working as it should be. So next up, we want to add the rest of our functionality, which will let our AI jump when it gets close enough, and then it will wait a few seconds before it continues. For this, we're going to need to create 2 additional tasks. This is done the same way as we created the other task. I'll speed up this part of the tutorial as it's not super necessary. Something that you should keep in mind whenever using the enter state node for your tasks is that for some reason, I believe this could be a bug, but for some reason, whenever you run your functionality in this code, in the return node, you should normally set it to succeed, but for some reason this does not actually register as succeed in the state tree, which will essentially mean that it results in the state tree getting stuck. So a simple workaround for this is going into your functions, override on your tick. You want to create a new variable called task completed. and set this as a bool. You're gonna want to create a branch here and set it connected to the task completed condition. And on true, you want to set this to succeed, but on false, you want to create a new return node and set this to simply running. This return node will tell the transition part of a state tree whether it should transition or not, or what the state is of the current task, so it can actually determine whether it should transition or not. So back to your enter state where you actually run your functionality. At the very end of your functionality, you want to set the task completed to true, and with that, you're done. This is a very simple workaround for what I believe could be a bug. For in version 5.1, this might be fixed later on, but for now, this is the only way I know that it actually would work consistently. So now I'll create the actual wait task. So now we'll create our wait task, and for this we'll just overwrite into our receive tick. We're going to want to add a variable called duration and set this to a float. If you want any variables to appear, for example, as in this right here, any variables that you want to appear here, you're going to need to remember to set the variable as a instance editable. You can do this by just pressing the eye icon here. We're going to want to create another child state of our root, name this jump, and then another one named wait. So our jump, we want to create a new task and add our jump task. We're going to want to bind it to our actor. That's done. In our wait task, we're going to want to add another task, add our wait task, and we'll simply set this to about 3 seconds. That's done. Now this is where we want to start setting up our transitions. So in our movement state, we're going to want to add a transition. And for this one, we're not going to set it to on state completed, but instead on tick. We want to add a condition. Search for the distance compare condition. Open it and set it to less or equal. For our actual source, we want to set it to our actor's location. However, by default, this does not appear. So instead, what we want to go is we want to go into our tutorial character. On tick, we simply want to create a variable and simply put it actor location. Put it as a vector. And on tick, we want to set this actor location to the location of this character. So get actor location and simply leave it on self and set it to here. Now with this, we can go back into our transition, into our condition, go into our source, bind the actor location. Our target, we want to bind it to our player location, and this distance we want it to be roughly less than 250 for now. So once this is done, we want to remember to actually set our transition to our jump. In our jump, we want to repeat the same thing where when the jump is completed, so when on state completed, we want to transition it to our wait, though you can also use next state as this is simply below it, and the way it works is any next state is considered anything below the current state. So if you use next, it's gonna just go to the one below it. And for our wait, we want to add a transition. On completed, set it to return to root. This way, it will loop around, and from the root, it will select the movement, and then go down, and then loop again. Now it is done. This means that if we play, we'll see our AI move towards us, jump very high, land down, and then try to move again. Maybe I set it too high. So now you can see how this works. The AI will move to us, jump, wait a bit, then move to us, jump. However, right now, as you can see, there's a bit of a weird behavior where the AI keeps moving after it jumps, when it should wait. When it lands, however, this isn't happening. This is because the simple move to location AI node is still executing, which means we were going to want to go into our movement task, create an exit state. This means that this kind of anything behind this node will get executed the moment the state exits. Here we're going to want to search for stop movement in the AI navigation tab. For this you might have to disable context sensitivity and simply set it to stop and reference it to the AI controller. This should stop the AI from moving when it lands, and as you can see now, it works as we want it to. It should move to us, jump, land and stop and wait, then repeat. So with this is essentially our AI. One thing you should note before we finish is that if you have multiple transitions, the way state trees work is they will first try to check if this transition can succeed, then the one below it, and then the one below it. Meaning if you have multiple transitions, it will check the very top one to see if that one can succeed, and if this one doesn't transition, it will check for the other one, and if this one doesn't, it will check for the other one. But let's say this one does, then it means that the anything below will never get to transition. So hopefully with this, you now understand how to set up an AI using state trees, and hopefully with this information, you're now able to create much more complicated AI. You could even make boss AI if you want. You could make simple enemy AI. Any type of AI that you'd essentially want, you can make use of it using state trees. Remember, if you want more information about state trees, check out the Unreal documentation, and this is essentially the end of this tutorial. Thanks for watching, and if you have any feedback, please note it down in the comments, and if you have any questions, also note it down in the comments, and I will check if I can answer them for you. Have a nice day.